So we're back again, back in the virtual demo room here in Kista. Today it's me, Roger, and Jimmy. Me and Jimmy will do some demonstration and some presentations. Roger will also do a little bit about explanation about some of the things with the thermal cameras. So it will be three of us today hosting this webinar. Topic of today is thermal cameras with intelligence. We are producing and manufacturing and developing thermal cameras. We just don't consider them to be only a thermal camera. It is what we consider to be a thermal video analytics device. It's kind of a sensor. So it's not just a camera providing a thermal image, it's a little bit more than that. In the session today, we will show you a few different examples of what we can do with them, and we will also do we will connect to the finished part of our demo solution on the rooftop in Vanta, where we will show you a few different things what we can do with the camera as well. But let's start with some basic information about the products. First of all, the fixed ones, the Danian Epithermals, is part of the intelligent video analytics family. They are for outdoor use, so they can be used in any kind of environment. And these cameras are really to be considered as a 24/7, 365 unit. Also, what I can say about these cameras, together with the MIC IP Fusion 9000i, it's used all over this Nordic region in quite a few different solutions where we're doing perimeter protection, where we're doing surveillance of harbors, about surveillance of borders, really covering long distances. And we have so many use cases where we have used these ones. So I think it's important for us to mention a few things, how we are deploying these solutions when we do this. That's also something Jimmy will demonstrate later on. So the Danian Epithermals are really used in an environment, and often we use them in combination together with the MIC 9000i. The MIC 9000i is a camera that has both a optical block and a thermal block, and we have what we call the fusion technology, where we are overlaying information between the two different camera blocks. But you have seen that one before. I will not demonstrate it too much today, but you will see a few examples how it looks like. But I would like to take a few steps back, and going back to the webinar we had about video analytics at the edge. Don't be surprised, and I don't think you are today, when I mentioned that the Danian Epithermal and the MIC Fusion are doing intelligence at the edge. So we're generating the metadata, we're creating the alarms and the events, and we're streaming the information together with the video stream to be able to search for this also in the forensic search way that we can do. This is also demonstrated in a few of our other webinars, so we will not do too much of forensic search on thermal cameras today. But it's the same methodology, it's the same processors we're using also for these thermal cameras. Going to IVA, in this case, intelligence at the edge. What are the differences if we compare it with a normal type of camera? There are a few things that are differentiating. First of all, we don't do video analytics on colors in the thermal cameras. Perhaps it makes sense. We don't do face detection, where we can find a face in the video stream. We don't do the idle and removed objects, and we don't do condition change. These are the things that differs between a thermal camera and a normal kind of optical camera. Otherwise, we're doing everything in the same way. So all the tasks you have seen, all the way how you create them, set them up, except out of these small differences, is available for the thermal cameras. I would like to start with the Danian Epithermal 8000. This slide shows a little bit about a few of the things why I believe, and I'm actually fully convinced, why this camera are so successful in this region. Reason is that if you look at the distances on these products, how long we can do video analytics on those cameras, it's really one of the main core things and the USPs. We often talk about unique selling points, but we're not. I would say this camera is not sold as a thermal camera. It is really sold as a thermal video analytic sensor. That is how we're using it, at least here in the Nordic region. Anybody can do a pretty good thermal camera, but doing a good thermal camera with strong, robust intelligence, and also to have it deployable in all these situations, that is really something that is not so simple to do. You also see some of the distances here. It's a bit differentiating between a QVGA camera and a VGA camera of the resolutions, and that is also related to how many pixels we're using when we do the detection. So this might be a little bit, it doesn't make any sense to have just this information, but I would like to show this slide. And in this one, I think we need to have to be able to explain it a little bit. If you look into this slide, you will see, first of all, some examples of Bosch products. These Bosch products, where you have the resolution and the focal length of the lens, you will see that we are able to do analytics at a certain length and at a certain width, and also at the specified covered area. And I use this slide to compare with just another brand out in the market that also are able to do video analytics at the edge. They're doing it a bit different than we are, because they're using a third-party algorithm installed on the camera to do this analytics. But what you really can see, if you start comparing the square meters of the covered area between the different solutions, you really start to see something that is quite astonishing. And for us, what we say when we're talking about these cameras as analytic sensors, you should consider the price you have to pay per covered square meter where you do your video analytics. Don't just compare the price of the product. Don't just compare the price of the product with the perhaps with the algorithm that you need to buy and the camera. You need to start comparing actually what distance you can do and how big area you can cover with one camera. That is really what should make the difference when you compare the price of a camera included with the analytics algorithm. So therefore I have this slide just to show you that it's quite a big difference if you compare, for example, two different 19mm cameras, where one is covering 4,000 square meters approximately, and the other one is covering more than 7,000 square meters. Also going into 7 and 7.5mm lenses, one is doing 3,000 square meters and the other one is doing 1,200. So you should look into the price of the product in combination with the algorithm and what kind of coverage you have when you do your analytics. So this is also important when you're comparing different products out in the market. But I would also like to show you a few things and some examples when it comes to these distances. We have different types of cameras, different form factors, different lenses, but I would like to tell a bit of secret. The camera block inside the metal Mickey and the Danian is exactly the same camera block. We just have different lenses, it's different form factors. What else? The video analytics. It's the same. It's the same algorithm in both cameras. One is fixed, one is moving. So showing you this video where we have a detection of a camera 225 meters away. It's the same if it would be in a MIC or if it would be in a Danian, depending on what kind of lens we have. So I would like to make a small break here in the video and just tell you a few things. If you look up here, the distance to this car running on this street is approximately 225 meters. So the MIC 9000i that has both an optical block and a thermal block, you will see very soon that you have an object coming into the scene that will create and generate an event. And this event that you see right now is detected in the thermal one and in the optical one. And at this point, we can start doing either just alarm and events by this information, or we could do some metadata fusion that I would like to show you later on as well. So it doesn't matter if it's in the MIC or if it's in the Danian, it's the same algorithm, it's the same thermal block, and it's the same type of configuration and setting up the system. So also, this is good to know, because if you know one solution, you will also know the other one. So we can continue to play this one, and you will also see the distance when we zoom out on this module, that it's quite far away from this camera down to U1, who is actually the guinea pig again when we did this recording previously. So that is one point of using a thermal camera. In this case, it was the moving one with the MIC. Within that one, when we have the two different camera blocks, we are also capable of doing the metadata fusion. Metadata fusion is the technology where we are combining the information between the two optical blocks. Between the two blocks, the optical one and the thermal one. And as you can see in this demonstration video, you will have an object that is on the thermal camera and also on the optical one. And when we start doing and overlaying this, you will see information from the different camera blocks in the other camera. Confusing? I will show you even further how it looks like so you can understand. This red thing is the metadata from the optical one. And here you can see in the thermal one that the camera has detected that the person is down on the floor. So you can see that the two different overlays from the different algorithms is shown at the same time. So you can use this information to view it at the same time in your video management system or in your software that you're using. I would like to use another video to display it perhaps a bit more clear how it looks like in real life. This is once again my colleague Johan. He is on his summer house, and in this summer house he has thrown out his friend in the cold water. And what you can see right now is that this object is being detected on the thermal camera block. You can see this dotted line, and that's actually the video analytics overlay coming from this optical block. So this one is generated from that one. So you will have the two informations visible at the same time. Now you will soon see a pretty interesting thing. On the left side here, you will see a person coming out here really soon, and here is Johan. Right now he is detected by the optical camera block, and at the same time you will see an arrow here. This arrow is indicating that something is moving on the left side a little bit down and is probably going to be a part of this scene as well. So if I play this once again, you will soon see that this object is moving and it's coming into the thermal camera block as well. And at that point, the operator might turn the camera to the left to see what is happening, or just wait to see if the object is approaching the thermal one. And after a few seconds, you will see that Johan is now walking out here and trying to say to his friend that you did a lousy job and you need to get back into the water again. No, Johan is a nice guy, so he will not say that. So this is also a way of using the different camera blocks in combination to get the information the user needs as the operator needs when he is taking a decision on what to do. So those are two recorded videos that we did before. You perhaps saw them when we did the session about the metal Mickeys. Now I would like to, in a very few seconds, hand over to Roger, who will talk a little bit about a few of the cameras we have on the roof in Finland in our demo room.
Thank you, Anders. So here we can see two cameras side by side looking at the same area from the roof in Finland. We can see the benefits of having two different systems, thermal and optical, side by side. Of course, the darker areas on the thermal camera are the hotter areas of the picture. So heat is reflected in the same way as light would reflect. If we freeze frame the truck there, we can see there's a thermal reflection on the side of the truck as it moves past from the vehicle that's repairing the road. The heat signature from that vehicle reflects on the side of the truck, which is rather odd, but that's an effect of thermal imaging. So if we continue playing the video here, we change over to a nighttime scene. At nighttime, you can see the thermal camera looks quite different to the optical camera. So the car headlights are not visible, they look black, same as the street lights. But you still have a lot of detail on both images, both thermal and optical. So now if we take a daylight picture again, we can now see the analytics working with the wireframe around the objects. And as you can see, the objects are different shapes, slightly different shape in the thermal camera and the optical camera because of the shadows and light reflecting off the road. Here, if we take the freeze frame, you can see there's a long glare off the road from the headlight, which makes the object look larger in the analytics on an optical image, whereas on the thermal image, it's the correct size. So I hope this gives you an insight of some of the benefits of having optical and thermal together. And now back to Anders.
Thank you, Roger. That was a bit of something just for you to get the feeling about the different cameras we have there in Finland. You also saw what Roger was mentioning here about the the weather situation they had in Finland a couple of minutes ago when we did that one. Now we will connect to the Finnish demo room by the remote portal that you saw in the previous session, I hope, one of our webinars. If you didn't see that one, please look at it again. It's really a nice way of connecting to remote site to be able to do all configuration of your systems. So we will have Jimmy now, who is already connected through the remote portal to this thermal camera that we're just showing an example of here, and to do some configuration and show you a little bit about how it looks like when you're setting up a alarm task in a thermal camera. So over to Jimmy.
Thank you, Anders. So now I am using Configuration Manager and I am connected through the remote portal just like Anders said. And here is the Danian Epithermal 8000 camera on the Finnish roof. Now I can start doing my video analytics.
But Jimmy, you already have two lines there. What have you done?
Yes, I have made two counters to count cars going east and counting cars going west.
Okay, and what I also can see that you have done some object classification, so it's just cars you're counting. It's not trucks and it's not bikes or motorbikes, it's just cars.
Yes.
Okay, good. So perhaps we should try to create some kind of alarm scenario with cars then.
Yes. So for example, I can make a new task and I can make an object in field. And I can name it anything I want. I will make it car and truck. And now I will select a field. So I will put a field for somewhere in the picture, like example here. And now I will also make another field. And for that reason is that I want to make an alarm for everyone that goes in the first field and then entering the second field, but not the other way around.
So it's actually a combination of these two fields making one task.
Yes.
Okay.
So now I have my two fields, field 1 and then field 2. I can press next, and here I can change if the car should go, if the alarm should go off in any field or if it needs to be in both fields. And I can also select the time span for this alarm.
So Jimmy, just quick explanation. Why do we do this? Is it to remove false alarms, or is it just to make a direction, or how is it used in real life today? What is your consideration about that one?
Some might think it's an issue that they have a hard time detecting with a line, and for some reason wants a bigger area. So they have a bigger area for detecting someone in a field.
Okay, so the combination is both for having a better false alarm immunity and also to be able to have a bit bigger area than just crossing a line.
Yes.
Okay.
Now I have selected to use both fields and I will press next. And here I can select that I want to make an alarm on cars and trucks. For this scenario, I don't want to change the height or width, but I can do that as well.
Yeah, and these filters that you're showing right now, we mentioned them in the IBA session we did. And also, if you would like to get more familiar and learn how to set up one of these cameras really in detail, I really recommend you to join and go to the Bosch Academy, to our training portal, to attend these trainings, because there are a lot of nice trainings there that will teach you how to do this in detail.
Correct.
Yeah.
And if I press next again, I also get the speed option, so I could make an alarm if someone is going below a certain speed if I would like to. And now I can press finish. And now we should have an alarm if a truck or car is going this way, but not the opposite way.
Okay, and you can also see that the counters have now been resetted. So if there will be cars coming, it will start to be counted again, going west or going east, as a completely different task in this camera.
Yes.
Since we can have 16 different tasks in a camera, you can decide to create a lot of nice scenarios, a lot of nice alarm and events situation, including data that is generated for other things than just security. So if you would like to have, for example, statistics about how many cars going west that has been speeding over 100 miles per hour or 100 kilometers per hour, you can actually make an event like that.
Yes.
Yeah. Okay, really nice one. Jimmy, a little bit about the settings we have for a thermal camera when we do the configuration, because previously there have been some questions about how long time it takes to set up a camera and do the calibration of the camera, and why we do the calibration.
Okay, so now I'm going to the calibration menu. It's under general and then camera calibration. And this camera actually have built-in sensors, and it actually also know its focal length. So the only thing you need to do is add the height for calibrating this camera.
And I see another thing here, Jimmy. You have some other nice and interesting information there a bit below. What is that?
That is the coordination system for the GPS. So you can also use this in different softwares to see where the objects are on a map, for example.
Exact. So if we go back again to the live position of the camera view, so we can see the video again, because I would just like to mention very briefly that all the moving objects you will see in this video, as soon as they have been detected, will have a dedicated geolocation position of exactly its position. So this person walking here will have an exact GPS position of its, at this case, its footprint of its object base point. So up to 30 objects approximately in each and every of these cameras can have a specific geo position.
Yes.
Yeah. So also, if you have a system that can read out the geo position of these IVA objects, you will also have the ability to show them on a map, for example.
Yes.
Yeah. So I would like to start rounding off this session today regarding thermal cameras. And as I said, it's not just a thermal camera. We consider them to be thermal video analytic sensors. That is how we see the cameras that we produce. All of the camera has built-in intelligent video analytics of a thermal cameras. You don't need to buy a separate license. You don't need to buy a separate server. Everything is done in the camera. Decisions are taken in the camera. You're configuring the camera, and then the camera is generating everything for you. Also including the metadata that later on can be searched afterwards. You saw in the example that we can do security things like triggering an alarm if something is moving, but we can also generate the data for other purposes. For example, business intelligence, or if you would like to have statistics of your traffic solution, that's also a possibility. So that was pretty much the kind of a short webinar we have today about the thermal cameras. But several of the topics we have been mentioning has also been done in other sessions with it, like the Metal Mickey with the fusion technology, some of the IVA stuff, and also everything when it comes to bitrate reduction and keeping the bandwidth low and stuff like that we have been mentioning before. So I hope you enjoy this one as kind of a teaser. If you would like to learn more about video analytics, how to set it up, configuring it, please contact us. register on our training portal, and welcome to the Bosch Academy. By that, me, Roger and Jimmy would like to say thank you all. Stay safe and hope to see you in a webinar soon again. Bye from us.